Here we've got a system of masses where you've got a smaller 10 kilogram mass resting on top of a 20 kilogram mass, and the whole thing is in an elevator that is accelerating upwards. Now we want to determine what is the acceleration of the elevator so that the force between the boxes and a scale, so imagine this thing's on kind of a physics bathroom scale that reads newtons. The scale reads a squeeze force, that's what scales do, so it reads a normal force of 300 newtons. So you can imagine that there's a scale underneath these boxes, like that, and that scale reading, which is reading the squeeze between the boxes and the scale, is reading a force of 300 newtons. So once again, let's isolate individual masses and the entire system and see what we come up with. So let's start with the entire system. If we imagine it as one big mass of 30 kilograms, 10 plus 20 is 30 kilograms, there's definitely a force of gravity down. Now what's holding it up is that normal force between the scale and the system. And that normal force is up. And we happen to know the value of it. It's the scale reading, it's 300 newtons. Now we want to know what the acceleration of those boxes are in this elevator. So there's the only forces that are acting on the system. So when I write my net force, which is always the sum of the forces acting on the box, it's going to be Fn minus Fg. Now we know Fn is positive because the question says it's accelerating upwards. And whatever the direction of your acceleration is your positive direction. It just makes the math that much easier. So now I can set it up and determine the acceleration. I've got ma on the left. My normal force upwards is given as 300 newtons. And my force of gravity down, as usual, is just mass times gravity. So my mass is 30 kilograms times 9.8. So when I crank all of this out, the right-hand side becomes 300 minus 30 times 9.8, which is 6. And my total mass, when I divide both sides by m, was 30. And 6 divided by 30 gives us our answer that we're looking for of 0.2. So the acceleration of the system is 0.2 meters per second squared up. Okay, now we want to figure out what that force is in between the boxes. Now, according to Newton's third law, it'll be equal and opposite. The bottom box, the 20 kilogram box, is pushing directly up on this 10 kilogram mass. So we'll call that a contact force, Fc. Similarly, the 10 kilogram mass, because it has inertia, is pushing back on the 20 kilogram as it tries to accelerate upwards. So there's an equal and opposite Fc force acting on the 20 kilogram mass. So now let's isolate just the top mass. What forces are acting on the top mass alone? Well, it has its own force of gravity down, call it Fg1. And then we can see from the picture, it's also got Fc up. Now we know it's accelerating upwards. So Fc must be winning. So when I write my equation for the top mass, I get F net is Fc, because it's going with the acceleration, minus Fg1. And solving it for that contact force will be F net plus Fg1. Now my net force is ma. And because we're only looking at that top mass, my mass is only 10 kilograms now. We know our acceleration, 0.2 meters per second squared. And then Fg will just simply be 10 times 9.8. So you end up getting 100 newtons of force for Fc, and when it's acting on the top mass, it'll be up. Now we should get the same answer when we do the bottom mass. So the bottom mass, what forces are acting directly on it? Well, I've got force of gravity down, which I'll call Fg2. Now it's going to be mass 2 times gravity, so 20 times 9.8, which is 196 newtons. So there's my force of gravity down. Now also it's directly in contact with the scale, which experiences a force of 300 newtons up. So I've got this normal force that's 300 newtons up. And there's a force from the 10 kilogram box pushing back on it that's down. And that's what we're trying to figure out, what Fc is. So when I look at that bottom mass, I've got 3 forces that I have to weave into my net force equation. Let me make a little room here. Okay, for the bottom mass, I get my net force, which is the sum of all the forces acting on that mass. Now remember, up is positive, so it's going to be Fn minus Fc, because Fc is down, minus Fg2. Now Fnet is always Ma, so it's going to be M times A equals F normal minus Fc minus Fg2. Now if I solve this for Fc, and I'll let you guys do the algebra, I get Fc equals F normal minus Fg2 minus Ma. Now we know the normal force, 300 newtons. We know Fg2, 196 newtons. The only thing left is Ma, so it's 20 kilograms times my acceleration, which is 0.2. And when I work all that out, I get the exact same answer of 100 newtons for Fc using the bottom box.